We explored push-pull when building the playground in the Getting Started course, so you may be familiar with the basics, but there is still more to learn. Open the exercise file to follow along, and let's review all the capabilities of the push-pull tool. We'll start with the ability to cut openings with push-pull. We can push a surface back until it meets a parallel surface, and the tool will cut an opening through both. The key here is a parallel and unbroken surface. You can see in these simple examples how non-parallel surfaces or other edges can cause problems. Two of these objects have non-parallel surfaces, and two of them have a back surface that is broken by other edges. Trying to cut openings doesn't work in these examples, so always be aware of the surfaces you are trying to cut an opening through. When trying to cut through a surface, it's very easy to push past that surface. Use the on-face inference to be certain when cutting openings. This can become more difficult when working on smaller shapes, so orbit for a better view as needed, or use inferencing. Start pushing on the front face and infer to an edge that is parallel with the back face. This is a good reminder to single-click your mouse to start and finish each action. It's easier and more accurate to click once on the front face to start pulling it, then click on an inference point to finish. Practice on more of these rectangles until you are very comfortable cutting openings and inferring with the push-pull tool. Now let's look at a different example of a few piano keys. We want to pull these keys up to the same height, and it's quite easy to do. Push-pull will remember the last distance that you used. So if we pull up one key, we can simply double-click to apply that same distance to the next key, and double-click again for the next, and again for the next. We could pull the black keys up to a different height and double-click on other black keys to apply that distance. Now I may accidentally pull a key too far, which means I've lost the correct height to finish the keyboard, but simply undo and use inferencing to establish the right height again, and then it's easy to finish out this keyboard. When using double-click to repeat the same distance, it's important to consider the direction you are pulling. For example, if I pull this key higher, that direction will translate to any surface that I double-click on. It will pull outward any other surface that same amount. However, if I instead push a surface down, now that direction will be repeated, pushing surfaces rather than pulling them. This is important to remember when trying to push or pull surfaces accurately. If I were to pull this floor plan up to an exact height, I could start pulling, type 9 feet and press enter to have a 9-foot high wall. To make this an 8-foot high wall though, I would simply push it back towards the ground, type 1 foot and press enter. If we now wanted to make this wall 10 feet high, what would you do? We'd start pulling the wall back up, type 2 feet and press enter to increase the height from 8 feet to 10 feet. Regardless if I'm pulling or pushing on a surface, I still enter a positive number either way. What's important is that you start moving in the correct direction, then enter the value you need, and the new push-pull distance will always start from 0, wherever your surface is. Another tip with push-pull is that you can use a modifier key to leave a copy of the surface you are pulling. Let me toggle X-ray mode on to help show this better. Normally, after you've pulled a shape into a 3D object, such as our wall, pulling again will extend this wall further. However, if you tap the Control key on a PC or the Option key on a Mac, a small plus icon appears by the cursor, and pulling on a surface leaves a copy of that surface. Remember to tap the modifier key each time you wish to leave a copy, and you can also toggle the copy off by tapping the modifier key again.